Hi everyone. So today we're going to be working on 1.2b. So we're going to be talking about different types of symmetry we can see in our graphs. So there's three types of symmetry that we're going to be focusing on. The images you see are straight from your textbook. They're from page 13. So either try to do a quick sketch of each of these or at least note what page number you can find these images again. If you're looking for like a refresher about what the different types of symmetry mean. So first, we're going to talk about symmetry with respect to the x-axis. So you should have learned about symmetry in geometry. So basically, if I took this graph and I folded right here along this x-axis, you would see that the two portions of the graph, the pink portion and the blue portion, would land right on top of each other. So we would say that this first graph right here is symmetric with respect to the x-axis. Like that's where the symmetry is coming from. In our second graph, we have symmetry with respect to the y-axis. So again, if I drew this dark line right here along the y-axis and I folded along that axis, again, you would see the pink portion would, the graph would land right on top of the blue portion of the graph. And so we would say that the symmetry in this graph is there with respect to the y-axis. And then maybe the hardest to see conceptually is the third type of symmetry we're going to be talking about is symmetry with respect to the origin. So basically, symmetry with respect to the origin is rotated 180 degrees around the origin. So if I took this point and rotated 180 degrees, it would land on that other pink point. Or same thing with this point. If I took this and rotated 180 degrees, either direction, right? I could rotate 180 degrees back this direction also. But I used the origin as my point of rotation. And I rotated 180 degrees, then I would land on that other point. So geometrically, that's how you have seen symmetry described before. We're going to look at symmetry in our graphs algebraically today. So we're going to look at it as a way to do it algebraically rather than talking about points of reflection or rotation the way you talked about it in geometry. All right, so to algebraically be able to talk about symmetry, we want to look at the points that they have labeled for us so far. So for example, on this first figure where we're talking about respect to the x-axis, go ahead and jot this down. If you haven't drawn the pictures, at least right now, write down symmetry with respect to the x-axis. I'm going to give you some information about that you're going to need in our upcoming examples. So right now, write down symmetry with respect to the x-axis. We're going to write down some things we notice about this graph. So graphs that have symmetry with respect to the x-axis, notice that the way the points are shown. So this point right here, this x comma y point, and notice they have x comma negative y. So basically what they're saying is that like maybe for example this is the point 1 comma 2, then that means the point 1 comma negative 2 is also going to be on the graph. Or maybe this point over here, I don't know, let's call that 6 comma 2, then that means the point that's across the x-axis, reflected across the x-axis, so 6 comma negative 2 is also going to be on the graph. So what we can write down is with respect, symmetry with respect to the x-axis, that if x comma y is on the graph, so basically saying any point on your graph, then x comma negative y is also on the graph. Okay, so again, to be a graph with symmetry with respect to the x-axis, if you're given a point, then that point, x comma y, then x comma negative y is also on the graph. So again, another example, if we were given the point 4 comma negative 5, then we know that x comma negative y is also on the graph. So that would mean 4 comma negative 5, right? Negative, but then we had the negative from the 5. So we would be able to convert that to be 4 and then positive 5 is also on the graph. Okay, and let's do one more example. So then, say for example, we have the point negative 3 comma 6. Okay, then we would know, so x comma negative y. So x stays the same, and it's the opposite of y, the opposite sign of y. Right? That's what the negative right here is telling us. It's the opposite sign of what it was in the original point. So x stays the same, and then we want the opposite sign of y. So therefore, if negative 3 comma 6 is a point on the graph, then negative 3 comma negative 6 is also on the graph. Okay, so that's what they are wanting us to notice. We're going to need those algebraic truths in a moment, but that's what they're wanting us to notice about graphs with respect to the x-axis, or symmetry with respect to the x-axis. All right, so let's go ahead and look at this. So go ahead and jot this down, symmetry with respect to the y-axis. Again, if you didn't draw the graph already, just at least make sure you're writing down the title, symmetry with respect to the y-axis. So you're noticing, again, the key features that they're wanting us to notice and getting it jotted down. So again, graphs with symmetry with respect to the y-axis. So what they're wanting us to notice is this point here, this x comma y point. I don't know, maybe that's 6 comma 4. Is going to be paired up with, that's what the little dotted lines are showing us. That's going to be paired up with negative x comma y. So notice it's opposite of x, same value of y. So if 6 comma 4 is on the graph, then negative 6 comma 4 would also be on the graph. So if a graph has symmetry with respect to the y-axis, then we know every given point, then we know the opposite of x, the opposite sign of x, comma y, is also going to be on the graph. All right, so just one more time. This is symmetry with respect to the y-axis. What they're wanting us to notice from the graph is that every point on the graph, whatever it may be, so say that point happens to be, I don't know, 4 comma 2, then we know the opposite of x, the opposite sign of x, comma 2, would also be on the graph. Okay, so again, let's use the same similar practice points I used last time. So let's say we have 4 comma negative 5. So if that point is on the graph, and the graph has symmetry with respect to the y-axis, that's the key here, y-axis this time, then we know it's going to have the opposite sign of x. So if x is currently a positive 4, then we know it's going to be negative 4. And we know y value is staying the same. So it's going to stay in negative 5. So in order for a graph to have symmetry with respect to the y-axis, we know the pattern that needs to be there. It means for every point, so for example, 4 comma negative 5, then we also know that the point, the opposite of x, so therefore negative 4, keeping the same y-coordinate, so staying negative 5, is also on the graph. Okay, let's do one more practice point again, negative 3 comma 6. If that point is on our graph, and we know that this graph has symmetry with respect to the y-axis, then we also know we want the opposite sign of y. So if y is currently, or sorry, opposite sign of x. So if x is currently negative, x is now going to be positive, and then keep the same y value, which happened to be a positive 6. So if there's a graph that we knew had symmetry with respect to the y-axis, if negative 3 comma 6 is on the graph, then we know 3 comma 6 is also going to be on the graph. Okay, so now, a little crazy with my line there. So now I want you to jot down symmetry with respect to the origin. And we're going to jot down, again, what we are noticing from the graph that they want us to be able to use algebraically. So in this problem, notice when we had x comma y, and notice the point it's matching up to the 180-degree rotation, it's negative x comma negative y. So it's the opposite of x and the opposite of y. So for example, if this was the point, I don't know, let's call this 3 comma 1, then we also know the point over here, negative 3 comma negative 1, is also going to be on the graph. If the graph has symmetry with respect to the origin, then we know it has to follow this pattern. Okay? Or another example could be, say this point right here is, I don't know, 1 comma 3. Then we know this point over here would be negative 1 comma negative 3. Opposite of x and opposite of y. So that's what the first thing they want us to jot down. If we have the point x comma y, then we know the opposite of x and the opposite of y is also on the graph. All right, so let's practice the same 2 practice problems we used last time. So 4 comma negative 5. If the point 4 comma negative 5 is on the graph, then and the graph has symmetry with respect to the origin, then we know that the point negative 4 comma positive 5 is also on the graph, right? Opposite of x, opposite of y. So opposite of x would be negative 4. Opposite of y would be positive 5, is also on the graph. Okay, again, so a graph that has symmetry with respect to the origin, if we're given a point x comma y, then we know the point negative x comma negative y, or opposite of x, opposite of y, is also going to be on the graph. All right, one last practice problem. So same point from before, if we had the point negative 3 comma 6, then we know that if a graph has symmetry with respect to the origin, we're going to do the opposite of x, the opposite sign, so positive 3, and opposite of y, so the opposite of positive 6 would be negative 6. So then we know the point 3 comma negative 6 is also on the graph. All right, so looking at our assignment for today, the 1.2b, the first section is 29 through 37 odd. right? So that's this section right here. And this is exactly what we just practiced doing. So what they want you to do is to take a point and then given that point, write down what other point you would know would be on the graph if it had symmetry with respect to the x-axis, the y-axis, and the origin. So I know you're doing the odd problem, so I'm going to take an even problem, and we're going to do that exact process. All right, so this is number 30 in the textbook. It's not one of your homework problems, but you're doing homework problems just like it. So I'm going to do a practice problem just like the homework, so you understand what they are asking. So they've given you this point, 5, 3, and they want you to do 3 things. They want you to, A, given that the graph has symmetry with respect to the x-axis, label what point would also be on the graph. So we know if the point 5, 3 is on the graph, then we know x, negative y, or x, the opposite of y, is also going to be on the graph. So A, with respect to x-axis, if 5, 3 is on the graph, then we know 5, keeping the same x value, and then the opposite of y, so the opposite sign of y, 5, negative 3 is also on the graph. And that's all you have to do for part A. So one more time to review. Part A is asking if the given point is symmetric to is on a graph that has symmetry with respect to the x-axis, then what other point do you know has to be on the graph? So if this graph has symmetry with respect to the x-axis, then I know 5, negative 3 has to be on the graph, because I know that x, negative y, or x, opposite of y, has to be on every graph that has symmetry with respect to the x-axis. B wants to know if the point 5, 3 is on a graph that has symmetry with respect to the y-axis, then what point do you also know is on the graph? So we know graphs that have symmetry with respect to the y-axis, that the opposite of x, so the opposite sign of x, negative 5, and then the same y value, positive 3, is also going to be on the graph. So one more time, if a graph has symmetry with respect to the y-axis, we learned in the notes we just wrote down that given a point, then we also know that negative x, or opposite of x, y, is also going to be on the graph. So if we have the point 5, 3, and this graph has respect to the y-axis, then the point negative 5, 3 has to be on the graph. And then C, what point do we know would have to be on the graph if we know the graph has symmetry with respect to the origin? So if we have this point 5, 3, and it's on a graph that has symmetry with respect to the origin, then we know the point, notice for origin, it's opposite of x, opposite of y, or negative x, negative y. So opposite sign of x and opposite sign of y has to also be on the graph. So again, if you have the point 5, 3, and it's on a graph that has symmetry with respect to the origin, then we know the point negative 5, negative 3 has to also be on the graph. All right, so that section of the homework, that's what it's asking you to do. They're going to give you 1 point, and they're going to ask you to do parts A, B, and C. List what other point you know has to be on the graph if in A, there's symmetry with respect to the x-axis, B, symmetry with respect to the y-axis, and C, symmetry with respect to the origin. All right, so that's what that section of the homework is about. All right, the next section of the homework is 51 through 69 odd, symmetry only. So in the directions, if they ask anything about intercepts, you don't need to do that tonight. In those sections, we're only focusing on the parts of the directions that are asking about symmetry. So 51 and 53, they're asking you to complete the graph so that it has the type of symmetry that is indicated. So 51, they want you to complete the graph so that it has symmetry about the y-axis. 53, symmetry about the origin. So again, you're going to take the points that they have labeled for you, using our notes, what we know about y-axis and origin symmetry, and then you're going to complete the rest of the graph. So I will do, again, number 52, something similar to the homework, but not actually one of your homework problems. All right, so x-axis symmetry. We know, based on our notes up here, if something has symmetry with respect to the x-axis, then x comma negative y is also going to be on the graph. So on all of these points, I know if a graph has x-axis symmetry, jot down my notes to myself, then I know x comma negative y, or x comma the opposite y, is also going to be on the graph. So the point 5 comma 3, then I know the point 5 comma negative 3 is also going to be on the graph. So 5 comma negative 3. And then the point 2 comma 0, well, then I know the point 0 comma negative 2 is also going to be on the graph. And then the point negative 4 comma 0, well, in this case, there is no such thing as negative 0. That's not a number. That's not a thing. So again, it would just be negative 4 comma 0. And then I could complete that portion of the graph. So I can see that the graph that I now have drawn by taking those points and taking the points that were given and then me finding their symmetrical point, I was able to complete the graph. And this graph now has symmetry about the x-axis. Again, so if I fold along this x-axis, the blue portion of the graph and the red portion of the graph are going to match up exactly. They're going to be mirror images right on top of each other. All right, so that's what that section of the homework is asking about. Now the last section, or the next section I should say, is asking you to take an equation and test for symmetry. So we need to do some more practice problems before we jump into that. Right, so this is the next section in the textbook, this 55 through 70. This is what we're going to go do practice problems for. So the next few practice problems we're going to work on are going to be similar to what they're asking you to do in this section. Now notice the directions do say something about listing the intercepts and testing for symmetry. But remember, our homework said in that section we only had to worry about the symmetry directions. So in that section, all we're going to worry about is testing for symmetry, which is the examples we're about to go do right now. Okay, so testing for symmetry, go ahead and jot down that title in your notes so when you get back to that section of the homework, you know where to come look. So if we're given an equation and we're asked to test for symmetry, we need to test for symmetry about the x-axis, then we need to test for symmetry about the y-axis, and then we need to test for symmetry about the origin. So when you're given an equation, you're going to have to run a test, and obviously I'll go through that. You're going to run a test for each type of symmetry we're talking about to determine whether or not that equation has that type of symmetry. So go ahead and write down example 1 under our testing for symmetry header, and that's y equals 4x squared divided by x squared plus 1. Right, so like I said, we're going to be testing for each type of symmetry. So we're going to, one at a time, test for a particular type of symmetry. So the first symmetry we're going to test for is symmetry about the x-axis. So I do want you to set up every single homework problem when we're testing for symmetry, set it up exactly like I'm about to, and you'll need to do the same setup on our lab and our quiz and test in this chapter. So for testing for x-axis symmetry, this is what I want you to jot down. You're going to jot down that we're going to replace x comma y with x comma negative y, or x comma the opposite of y. Okay, so that's the note that you're going to jot down to remind yourself and to tell me, that's why it's important to tell me that you know how to test for x-axis symmetry. And the way you're going to test for it is you're going to replace x comma y with x comma negative y, or x comma opposite of y. So here's how we're going to do that. In the equation, anywhere there's an x, we're going to leave it as x. In the equation, anywhere there's a y, we're going to replace it with negative y, or opposite of y. So in this particular equation, there is only one y value. So right at the beginning, the first y value, I'm going to replace that with opposite of y, or negative y. And then we're going to go to the right-hand side of the equation. We have 4. I have an x, but my directions say leave it as just an x. I have another x, but again, my directions that I wrote down to myself say leave it as just x plus 1. So what we're doing is we're testing to see if this has symmetry about the x-axis. And what we're looking for is, does the equation come out to be exactly the same as our original? So if we go in and we replace x comma y with x comma negative y, or x comma opposite of y, if we go in and replace it, and after we do all the simplifying that we're allowed to do we get back to our original equation? That's what we're asking ourselves. That's what we're trying to determine. Well, looking at this blue equation right here, is that saying the exact same thing that we have up here at the top? No, it's not. Because the left-hand side is still saying negative y. We could try to multiply both sides times negative 1, right? It's an equation, it's balanced, it's fair, you're allowed to do that. But negative times negative, so right here, negative 1 times negative y would get me back to positive y. But when I try to multiply the right-hand side, it stays negative. And so I'm still not back to matching my original purple equation. So in this case, that didn't help. Trying that, sometimes that helps, the little kind of trick of multiplying by the negative 1. Sometimes that can help us out, but we saw in this case it did not. And so we would say it is not symmetric about the x-axis. Okay, so this particular equation does not have symmetry about the x-axis. Right, and then we're going to go right next to that, and we're going to write down y-axis. And again, this is how I want each of the homework problems set up in this section. And this is what it's going to look like on our lab and our quiz and our test, to show me that you know how to test for y-axis symmetry. So again, you're going to write down replace, and you're going to replace x comma y. But this time when we're testing for y-axis symmetry, if you look back up at our notes above, it's negative x comma y. So that's telling me that each x I'm going to replace with a negative x, or the opposite of x. And each y is just going to stay as a y. Okay, so we're going to do that replacing into that purple equation and see what we get. So again, for y, it's staying the same. So it's just going to stay a y. But for each x, I'm replacing it with a negative x. So I have 4, but then I have an x. So I'm going to replace that with a negative x, but it's being squared. I have another x that I'm replacing with negative x, but it's being squared, plus 1. Right, so now I need to go through and simplify, see what I can simplify in my equation. So in this equation, I have negative x squared. So a negative x times a negative x. Well, negative times a negative, that's getting you back to a positive. And then x times x, that's an x squared. So negative x times negative x, that's back to just a positive x squared. And then the next place I have somewhere where I can actually simplify, I have the same situation. I have a negative x squared. So negative x times negative x times negative x is back to a positive x squared. And then there's nothing to simplify with a plus 1. It just stays a plus 1. So I did my replacing. I replaced all the x's with a negative x. I left all the y's as just a y. And then I did my simplifying. And now I'm looking to see, is this green equation I just wrote, is it exactly the same as the purple equation? And in this case it is. It does match exactly. So even though I replaced all the x's with negative x, once I simplified, I got back to my original equation. If that happens, then you will say, yes, it is symmetric about the y-axis. Okay, so in this case, we would be able to say, yes, this particular graph does have symmetry about the y-axis, because after we did our substitution and we did our simplifying, we got back to the exact same equation. All right, and then the last one we're going to do is we're going to test for symmetry about the origin. So again, I am going to ask you to set up all your homework problems exactly like this. You're going to write down replace x comma y, and we know from our notes above that if something has respect to the symmetry with respect to the origin, then the point negative x comma negative y, or opposite of x comma opposite of y, is also going to be on the graph. All right, so now we're going to do both. So each x I come across, I'm going to replace with a negative x. Each y I come across, I'm going to replace with a negative y. And so here we have a y, so I'm going to replace that with negative y. 4 is just a 4. But then I have an x squared. So each x I'm going to replace with negative x, or the opposite of x. I have another x, so I'm going to replace that with a negative x. The squared's still there. Notice I put parentheses around it when I substitute in. And then the plus 1, there's nothing to substitute there or replace there. Okay, so we've done the replacing part, the first step of our directions. And now we're going to do the simplifying. Negative y, there's not much I can do there. It's going to stay a negative y. And then here, again, or the 4 is just a 4. But again, with the negative x squared, that's saying negative x times negative x. So a negative times a negative is a positive. X times x is back to x squared. And then again here in the denominator, I have negative x squared. So negative x times negative x, that's a positive x squared. And then plus 1. So I did my replacing. Then I did the simplifying. And now I'm checking, does this red equation I have match the original purple equation? And it does not match it exactly. Again, for the same reason as before. The left-hand side should be just y, and this is a negative y. And so in this case, again, we would say it's not symmetric about the origin. Okay, so this particular equation would only have symmetry about the y-axis. So this is what they're looking for us to do in that section of homework. I think it was like 55 through 70. That's what they are asking us to do when they ask us to test for symmetry. So we're going to do a few more examples, just so you can feel a little bit more confident with this idea. So go ahead and label this example 2. We're going to have y equals 1 over x. Okay, So again, this is how you need to set up each homework problem. You're going to write x-axis. So tell me what it is you are testing for, which type of symmetry you're testing for. And then you're going to write replace x comma y with x comma negative y. So for testing x-axis symmetry, those are our directions. And so you have to have that sentence there so I know that you know how to test for it, right? So you're telling me what it is you're about to do. So that's one thing I will check for on the lab and the quiz and the test. Were you able to tell me how to test for x-axis symmetry? So that's part of the credit. And then the other part of the credit is, did you test correctly? But this is part of it, being able to tell me at least what you should do. So again, this is telling me for each x, I'm going to leave it as x. For each y, I'm going to replace it with negative y. So on the left-hand side, I have a negative y. And then 1 over x. The x stays a positive x. So step 1 is to do the replacing. Step 2 is to do any simplifying that you could do. So again, sometimes we need to multiply both sides of the equation times a negative 1. Especially when you have that negative y, sometimes that's what it needs as part of its simplifying step. So it's something we can always try. So negative times negative would be positive y. But negative 1 times negative 1 is still going to be a negative 1x. So the blue version that I had, or my attempt to try to make it better, which was the green version, by multiplying both the left-hand side times negative 1, neither of those match the original equation exactly. Neither of those match the red equation perfectly. So we're going to say this is not symmetric about the x-axis. Right, and now we're going to test for y-axis symmetry. So again, tell me what type of symmetry you're testing for. Tell me how you're going to go about doing that. So you're going to replace x comma y with negative x comma y. So the opposite of x comma y. All right, so again, the y value that we have here is just going to stay y. In the x value spot, I'm going to replace it with a negative x. So the 1 is just a 1, but in the denominator I have an x. I'm going to replace that with negative x. So right now that purple does not match that red. But again, like I said, sometimes you need to multiply both sides times a negative 1. Sometimes that's the simplifying fix that we need. So negative 1 times y would be negative y. Negative 1 times negative x gets me back to that positive x. But the problem is that green still doesn't match. So in this particular case, that again was not helpful. So I tried one of my simplifying techniques because I didn't have anything else I could do. But it still doesn't match the red one exactly because of the negative that's over here. So again, I'm going to say this graph is not symmetric about the y-axis. All right, and then the last thing we're going to test for is symmetry about the origin. So again, you're telling me what type of symmetry you are testing for, and then telling me your directions. So in this case, it's replace x comma y. Make that look more like an x. X comma y, and you're going to replace it with negative x comma negative y. Okay, so again, that's needed in your homework and the lab and the quizzes and the test to tell me that you know how to test for symmetry about the origin. Then you need to actually do it. So in this case, each x is being replaced with negative x. Each y is being replaced with negative y. So the y is getting replaced with negative y, or opposite of y. The 1 is just a 1. The x is getting replaced with negative x. Now, again, this looks like, I'm just spacing this out a little bit. It looks like it doesn't match the red. But that trick I've been trying all along, I'm going to try it one more time. So I'm going to multiply both the left and right hand side times negative 1. So negative times negative, that gets me back to a positive y. And negative times a negative, that gets me back to a positive x. So remember, it's an equation. As long as I multiply both sides times the same number, which happened to be negative 1 this time, as long as I'm equal and fair and I multiply all the terms on each side times that same number, then it's still a balanced equation. And notice, this time when I did that, it does actually end up matching exactly back to the original. So in this case, I know it didn't look like it when it was written as the black equation, but we showed that it really was by multiplying both sides by negative 1. So in our simplifying, we showed that it actually was the same. And so then we could say, yes, it is symmetric about the origin. All right, so I'm going to try to do one more example. I'm going to do it a little bit quicker because I'm going to try to get it finished in just a couple minutes so we can get it watched in class. But if for some reason I don't get to complete it, the lecture notes are also going to be posted in Canvas. So if you feel like you need the help, you can definitely just go to the video in Canvas, fast forward to this point, and watch from there. All right, so again, we're given this equation. We're asked to test for symmetry. So we're going to go through the 3 types of symmetry that we're working with in this section. So x-axis symmetry, I'm going to replace x comma y with x comma negative y. All right, so in my equation, x is going to stay the same, but wherever there's a y, I'm going to replace it with negative y. And notice I put it in parentheses. The squared is outside the parentheses. So I did my replacing. Now I need to do my simplifying. So this right here is saying negative y times negative y. So 4x squared stays the same. Negative y times negative y is a positive y squared, and then it's still equal to 4. So we did our replacing in red, then in blue we did our simplifying, and now we're checking, does that equation match the original green one exactly? And it does. So we could say yes, it is symmetric about the x-axis. All right, so then next we would be testing for y-axis symmetry. So again, you're going to tell me your directions, like what you're planning to do. So we're going to replace x comma y with negative x comma y, or opposite of x comma y. All right, so let's go ahead and do that. So we have 4, but then the x that's in the equation, we're going to replace with a negative x, or opposite of x squared. Notice when I did my replacing, I substituted in, I put in the parentheses. The squared is still outside the parentheses. Then I have y squared equals 4. All right, so this section right here, the negative x squared, is really saying negative x times negative x. So we still have the 4. Negative x times negative x. A negative times a negative is a positive. X times x is x squared. Plus y squared equals 4. So again, in the purple, we did our substitution. Then we simplified everything that we could. And now we're checking, does the green equation match the black equation exactly? And it does. So we could actually say yes, it is also symmetric about the y-axis. Right, and then lastly, we're going to test about the origin. So again, our directions that we know we have to write down, we're going to write replace x comma y with negative x comma negative y. So each x and y is going to get replaced with negative x and negative y. So 4, again, the x is getting replaced with negative x squared, plus now the y is also getting replaced with negative y squared equal to 4. So this 4 drops down. Negative x times negative x. Well, a negative times a negative is a positive. And then x times x would just be x squared. And then again, our next section, negative y squared. That's really saying negative y times negative y. So negative times a negative is a positive. Y times y would be y squared. And then still equals 4. So now we're asking ourselves, does that simplified blue equation match the original green equation exactly? And it does. So this particular graph is also symmetric about the origin. And if you remember from geometry, this particular graph is a circle. And so that's why it had with the center at the origin. And so that's why this particular graph has all 3 types of symmetry, is because it's an actual circle. Okay, so that's the last example for this section. So in here, problems 59 through 69, when they're asking you to test for symmetry, that's what they're asking you to do. Those last 3 examples we just did, that's exactly what they're looking for in this section. And then in the homework, 75 through 81 odd, they're asking you to use what we have learned about symmetry and to try to answer the question. And then 81 is another kind of word problem relating to symmetry. Right, and then that was it for tonight's homework. If you have any questions, please let me know. And again, this video I will post in our Canvas class as well for you to watch later if you need to, if you need to rehear something, that'll be there for you as well. All right, guys, I'll talk to you later. Bye.